It's my pleasure to introduce the next speaker. It's Kevin Newton, and he'll be talking about the future of understanding Ruby code. Kevin is a Ruby core committer and a staff engineer on the Ruby infrastructure team at Shopify. He's based out of Boston, Massachusetts. He's passionate about music, accessibility, and open source software, of which he creates a lot. He has also received the Ruby Prize 2023 last week in Japan for his that was for his work on the new Prism Ruby parser. So please put your hands together for Kevin.
Before we start, I was just on the phone with my son. I live in Massachusetts, and there are wild turkeys in our yard, and he's sobbing. He's 3, so can everyone say hi, Henry, on 3? He's going to lose his mind. I'm not FaceTiming him. This is a video. But ready? 3, 2, 1. Hi, Henry! You guys are the best. Thank you. All right. Let's see if my clicker works. OK. This talk is entitled The Future of Understanding Ruby Code. Come on in. Yeah, come on in. The concepts we're going to present today are somewhat technical. If you are a more experienced programmer, I hope that this inspires you or gives you something to think about. If you are a less experienced programmer, I want you to let it just wash over you. I want you to treat this talk like a Wikipedia article. There will be links. There will be tons of things for you to dive into later. Don't take notes. I'll post the slides. But just kind of try to enjoy it. So, we're going to do a little exercise. I want you all to put your hands up in a second if the code on the screen makes sense to you. So let's raise our hands. This is a regex. Great. Put your hands down when it's... Raise them up. Put your hands down when it stops making sense. All right. It's a method call. Yeah. The space. Yeah. OK, so what have we demonstrated? We have learned that there is syntax that is very weird in Ruby. We have learned that looking at, talking to different people about what this is going to do is not going to be sufficient because there were only 2 people in their hands with their 2 people in the room with their hands up. All right? So let's think about this. What does this code do? This is not an important question. This is the important question. How would you find out what this code does? I want you to think about that for this talk. We're going to come back to this at the end. So let's talk about dependencies. My son, Henry, he's 3. Every morning, he says the same thing. Dadu, let's go build towers. So let's build some towers. Let's start with your application. You build an application. It depends on external libraries. You think of something like Rails. External libraries depend on standard libraries from Ruby. Standard libraries from Ruby execute yarv bytecode internally. That depends on the compiler, which builds the bytecode. That depends on the parser, which builds the AST, which gets compiled. And that depends on the Ruby source code. OK, we built our tower. Great. So let's do a very, very quick whirlwind tour of what this means. You start with your Ruby source. This is Ruby source that comes from Sidekick. You can call this method in Sidekick. The parser will parse this into a set of tokens. That's Alexa's job. It then parses it into an abstract syntax tree. The compiler then takes this and walks through the tree to build our instructions. And the form right now is in a linked list. This is what a compiler is doing, is building the linked list. From here on out, we're going to build something called instruction sequences, which is the bytecode, otherwise known as an intermediate representation. This is going to be able to call standard library methods like puts, and then you can go and this instruction sequence is something you have built. This is an external library. This all lives in your application as this. This is our dependency tower. OK, let's fill this in for CRuby. So parse.y is the current parser for CRuby. Then you go passes through compile.c. This builds yarv instruction sequences, which fuel the standard library for CRuby, which powers the gems on Ruby gems, which powers your applications. Great. So let's talk about this for other Ruby implementations. Let's talk about JRuby. JRuby uses something, another grammar file, rubyparser.y. It then builds an IR using irbuilder.java, which builds the JRuby IR, which builds the JRuby standard library, which builds most gems on rubygems.org. Sometimes you have to patch in Java for native extensions, which works on almost all applications. Great. Let's talk about truffle Ruby. RubyParser.y, which came from the same origin but is slightly different now. Translator.java to build the truffle AST. Has the truffle. It's not really a bytecode as much as it is an AST that gets walked, but that doesn't matter. Builds the truffle Ruby standard library, which works on most gems on rubygems.org, which works on most applications. Okay, let's talk about Natalie. Natalie has its own parser-ish. Called the Natalie parser, which goes through pass1.rb, which compiles things into the Ruby instructions that are declared in Ruby in the instructions directory, which builds the Natalie standard library, which works for most gems on rubygems.org, which works for most applications. Okay, so we have all of these different things. What happens when Ruby source changes? What I mean by Ruby source changes is I mean new syntax is introduced, some kind of breaking change. And don't get me wrong, they are breaking changes. So the pink is going to represent different things. Okay, so CRuby is where these things happen. This is the canonical changes. Parse.y gets updated, compile.c gets updated, urv gets updated, everyone's happy. Everyone else starts working on their parsers to go and update. Great. We get a little bit farther with JRuby, and we get a little bit farther with Natalie, and then Ruby source changes again. Oh no. Well, very quickly, CRuby gets updated because that's a canonical implementation. And maybe Natalie gets a little further into the instructions. Truffle Ruby gets further into the translator. JRuby gets further into the the grammar file because they figure you may as well just update those changes. And then Ruby source changes again. You're starting to see the problem, hopefully. Suffice to say, it's not easy. Okay, so let's do the same thing, except instead of Ruby runtimes, let's talk about tools. We have a Ruby source, we have a parser, compiler, and bytecode. We'll fill this in for CRuby again. We have parse.y, compile.c, and yarv. Let's fill this in for the tools that we know and love. For instance, the parser gem. This is the white quark parser gem. It's written in Ruby. It uses a parser generator, and it provides the ability for you to access the syntax tree. RubyConf is built on the parser gem. Great. Oh, but there's also the Ruby parser gem, and that builds faster, among other things. There's also tree-sitter Ruby. Oh, yeah, there's that too. Oh, and there's also Ripper, which builds my gem syntax tree. Then you can go and work on the IR level. But the thing is, this only works in CRuby, but there's Ruby VM instruction sequence. And actually, there are lots of things that work on top of that. There's typeprof, there's tenderjit, there's innumerable gems. So we have these dependencies. And you can see they're extensive. This is a very small subset of all of the dependencies that are out there. But the dependencies that you depend on in your tooling, that you use day to day, I mean, you obviously aren't going to use all of these, but you're going to use some of them, is all dependent on Ruby source in all of these parsers. What happens when Ruby source changes? Suffice to say, things don't go well. So, every different representation of Ruby leads to different assumptions, implicitly. They don't mean to. They want to represent Ruby in the same way, but it's very difficult to represent Ruby in the exact same way without running the exact same code. Every tool that I've mentioned, because they're all using different underlying assumptions, different foundations, it requires contributors to relearn how to contribute to these things. None of this knowledge leads you to be able to contribute to CRuby, which is where you should be contributing. Let's be clear, we have a language. The canonical runtime is CRuby. If we're going to exist for 30 or 100 more years, we need you to contribute. Working on these other tools doesn't lead you to contributing to that, and that's a problem. Maintaining a Ruby parser is a massive maintenance burden. Ask me how I know. Every time new syntax is introduced, every parser has to update. There's a guy named Tom Anibo who works on JRuby, who has been maintaining the JRuby parser for over 10 years. And I am always in awe of him, because the way that he maintains the JRuby parser is by looking for git commit changes on parse.y and then translating that code every time into Java from C. That is a heroic effort. That is a heroic effort. He should have gotten the Ruby prize. This is ridiculous. Very minor changes to the grammar have massive implications around the ecosystem. I was just talking to Vinny, my coworker, who has a bot set up on the parser gem to listen for changes so that he can update RubyLSP. The parser gem has a bot that listens to changes on parse.y so that they can update the parser gem. This is insanity. Helping Ruby by introducing more syntax, by making things better, can inadvertently hurt the entire ecosystem. This is a terrible situation. This is what leads to what I'm calling a fractured ecosystem. So let's talk about parsers. In existence, there is the canonical parse.y in CRuby. There's Ripper. libruby parser is a Rust parser. There's mruby's parser. Sorbet is using TypeRuby's parser historically. There's Whitecard parser gem, the Ruby parser gem. These are all actively maintained. Well, almost. Let's talk about syntax trees. Parsers can generate different syntax trees. For instance, the CRuby parser generates 2 different syntax trees, one in the C API, one in the Ruby API. Ripper can build 2 different syntax trees, depending on the options that you pass it. I have my own for some dumb reason. They just keep going. This is a fractured ecosystem. So let's read this comic. So what did I do? I made a new one. I'm so proud that that comic, it actually lines up to 14. So, if all of my pull requests are merged, this is what we're going to start to see. I want to be very clear that the function of these pull requests to remove these parsers is not to say that they are bad parsers. They are very good parsers, and they have served their time. And they have done very, very well. And the issue is not the writing. The issue is the maintaining. And the thing is, none of the amazing people that work on these parsers should have to work on these parsers, because they should be able to work on the things that come after parsing. Parsing, you saw, was the second lowest thing in the stack. We shouldn't have these incredible contributors working that low. They should be able to work on the things that make their runtime amazing. JRuby is rolling out support for fibers. That's incredible. We want to have that kind of thing around the ecosystem. We want to have people be able to operate at the IR level without, oh no, pattern matching came out. Let me spend 3 years catching up. That is a waste of our talents. That is a waste of the effort inside of the community. So, in theory, no longer fractured. I just love keynote transitions. So I want to talk to you about Prism. Prism is a new parser. It was built around 5 design goals. Compatibility with CRuby has to be 1-to-1, as Matt's mentioned. Compatibility, he learned. Maintainability, we want the parser to be as maintainable as possible, as easy to contribute as possible. We want it to have as much error tolerance as possible so you can get great error messages in your terminal. We want it to be portable to every single Ruby runtime, to any Ruby tool, any kind of language you want to write and access the Ruby syntax tree, you should be able to. And finally, we want it to be performant, both in memory and speed. So I'll give you a bit of the timeline of how this went down. About 2 years ago, a little more than 2 years ago, actually, I started working on a prototype for this. It was called Ruby Parser at the time. It then got renamed to YARP. It then got renamed to Prism. We had the first call with the CRuby team where we introduced the concept and said, hey, can we please do this? And they said yes. We committed the first commit to YARP later that year. In April of last year, I had my daughter. My wife had my daughter. I took some months off, but in the time that I was gone, Truffle Ruby made its first commit to using this as its main parser. JRuby made its first commit to using this as its main parser. CRuby, Gemma Ezroff, used the parser to build the first instruction sequences. When I got back, I started working on porting syntax tree, the formatter, to use this AST instead. Made a commit to the parser gem to use this as a separate backend, and we renamed to Prism. This is like not all of the details. But, so how was it built? What did we do? So designing a new syntax tree and a new parser comes with a lot of pitfalls. The first thing we did was we looked at every single parser that I just mentioned, and we tried to find the best pieces of each of them, which was not easy. As I said, they all make different assumptions about Ruby code. We did a comparison of semantic nodes versus syntactic nodes. Now this is kind of an important point, where some nodes represent the syntax that you used. We wanted to represent the code that you were trying to run. For instance, if you have an assign node, which has a left and a right, the thing on the left is being assigned to, the thing on the right is the value. That doesn't mean anything semantically, because if you're writing to a constant versus writing to a global variable, those have very different semantics. So we wanted to have only nodes that represented the semantics of the tree and not the syntax of the tree. But we wanted to provide enough information that all consumers to use this in any way. So if you wanted to use it as a linter, you can still get back to the fact that it was an assignment, but it wasn't the default. So, designing for Ruby implementation. So I'm going kind of fast. I did 299 slides. I'm not sure if I'm going to get through all of them. Anyway, designing for Ruby implementations means making compilation as simple as possible. We wanted to never have to check a child node, as I just mentioned with the assign node. You don't want to have to go further down the tree to understand what you're currently compiling. And we wanted to cover as much common functionality as possible. We wanted to provide all of the benefit to all of the runtimes at the same time. Designing for tooling means named field and known types. Almost all Ruby parsers out there give you S expressions with a big old array. That's a pain in the butt if you want to actually do something useful. So this provides named fields. You go to a node, you have a call node, you ask for .name. That gives you the name of the method being called. So we need named fields because then the underlying implementation can change, and we have that abstraction layer to protect us from those changes. We wanted to provide nodes with enough information to round trip back to the source. So you should be able to replicate the source exactly. And we provide location information for as much as possible. So one of the downfalls of a lot of the existing syntax trees is that they don't provide information about where things specifically were in source. If you have like a then keyword or an if keyword, a lot of the time you'll get an if node, but you won't find out where the keyword was. A lot of the time you need that for linters or static analysis. Designing for maintenance means templating as much code as possible. We template from a YAML file, believe it or not, a lot of our code. We provide as much documentation as possible, and we build up as big of a test suite as possible. There isn't really an existing test suite for Ruby syntax. We are trying to build that actively. So let's talk about challenges. Encoding. This is a magic encoding comment that lives at the top of your file. There are 90 possible source encodings for CRuby, 154 aliases. We support about 30. We'll get there. We have to support them all if we're going to be compatible. Escaping. Those are your basic escape characters inside of strings, but also those, and those, and those, and also these. Ooh, the way we solved this is by brute force testing every single possible combination, every single possible context. We did get this right. I'm happy about that. Regular expressions. You have to know all local variables in a given scope to parse correctly, because as we know in Ruby, local variables can be confused with method calls. So you have to know what local variables are available. Regex can introduce local variables through named capture groups. So we built a regex parser. Here docs suck. They were a mistake, and I'm not sad I said it. Yeah. Declarations function as any other expression. So the less than, and the name, that functions as any other expression in the tree, which means that on every new line, every time you hit a new line when you're parsing Ruby, you have to check if you already saw a here.declaration and then go parse it. It functions as a stack of queues or a queue of stacks or some other BS. Anyway, so what's the current? That is the short list of challenges, let me tell you. We've been working on this for 2 years. What's the current status? So let's talk about the current status. In the C, so we have 3 APIs that I'm going to tell you about. We have the C API. Ooh, we're getting kind of close. We have the C API, which is used in CRuby, Natalie, Rust tooling. We're exploring it to replace the sorbet parser, the artichoke parser, which currently embeds the mruby parser, other C, C++, Rust, and Zig tools. That's not just a list of random languages. I literally know people that are using this from Zig. So it is possible. This is how we do it in CRuby. There's a method that is defined in C that is on the Ruby VM instruction sequence class that you can call compile prism. This is how it's done in Natalie. You can call prism.parse from the Ruby API, which is actually compiled to C++, so this is actually the C API. It's the whole thing. We also have the Ruby API. As I mentioned, Natalie uses it. Other Ruby tools are using it. This is how it's done in my parser prism gem. This is a gem that I've been working on that allows you to replace the underlying parser that is being used to power anything that is run by the white quark parser gem. So you can use this gem, and you could do a really weird thing with your RubyConf YML and run Prism as the backend of your RubyConf run. And last time I checked, it was like 3x faster. So there's a lot of bugs. Let me say that. Let me say that up front. There's a lot of bugs. We also have a serialization API. I want to talk about this real fast. This means parsing an AST and then serializing it to a binary stream such that you can call it from FFI, but you only have to make one function call. This is very important for languages that have FFI through different means. For Truffle Ruby, this means JNI. For JRuby, this means JNR. Either way, it means making one native call and getting back a binary stream. So when that happens, for instance, this is how it happens in JRuby. They call PM serialize parse, which is one of the functions embedded in our C library with a buffer, and that returns to you the stream. This is how it happens in Truffle Ruby. These are all examples from real code that is running. So we've already integrated into these systems. And this is how it happens in JavaScript. We compile Prism to Wasm or Wasi or one of the other Wasl. I don't know. But you can access the AST from JavaScript now. You can access it in the browser. Great. So what's next? Next year, we are going to be focusing on making error tolerance so much better. We want to focus on the messaging. We want to focus on making it so that you have the best experience in your editor whenever you are working with the Ruby AST. Performance enhancements, there are so many things we can do to make this faster. So the CRuby parser, as it currently exists in CRuby, not Prism, is historical. The thing is, the CRuby parser is generated by a parser generator, previously known as Bison. There was recently a Ruby port to that, which is using something called Llama or LRama, depending on who you ask, which is a Ruby port of Bison. This is a parser generator. Parser generators like this are typically used to generate what is called a context-free language. Context-free languages are within a hierarchy of languages that delve into different levels of complexity. Ruby is not a context-free language. Ruby is a context-sensitive language, which is to say you need more state in order to properly parse it. But the parser generator is generating a context-free parser. What does this mean? It means in order to feed the tokens into the parser, we have to maintain a ton of state in a separate program that effectively controls the parser. The reality is Ruby has an incredibly complicated grammar, one of the most complicated in the world. It's not a context-free language. Using a context-free parser generator is a mistake because you're going to have to maintain a ton of state that doesn't line up. You're using the wrong tool for the job. The right tool for the job is a handwritten recursive descent parser like the one that we have written. This is why we built this. It fits more to the problem. It's the right tool for the problem. Just got off on a big tangent. Performance enhancements. Right, the reason I said all that is because it is a handwritten parser, we have the opportunity to do more things that a generated parser cannot do. We have more control because we wrote the program. We're not generating the program, we wrote it ourselves. So we can do some very interesting things. One of the things that I would like to do early next year is do an arena allocation for all of the nodes so that they're right next to each other. I would like to continue an investigation that I started earlier this year of using automatic vectorization like SIMD instructions for our lexer. I would like to take the state out of the lexer and start pushing it into the parser so that it's one-to-one, so we don't have this kind of weird state. The reason we have a separate lexer and parser that talks to each other is because we had to migrate it from the previous one. So we migrated as much code as possible that was one-to-one. But we can start to change that now that we actually parse things correctly. When Ruby 3.3 rolls out, Prism is going to come in the mail for Christmas. And when Ruby 3.3 comes out, we're going to have to freeze where it currently is and then to start support multiple versions. So that's going to come next year. Further integrations into the ecosystem. If you know of a gem that is using Ripper, tell it to stop. Or tell me and I will tell it to stop. We shouldn't be using Ripper anymore. If you go into the comment in Ripper at the top of the file, it says, early alpha version, experimental. It has said this since the early 2000s. Improved Ruby library for external tools. So we have our C API, we have our serialization API, but we also have our Ruby API. Our Ruby API is nice objects, named types for every single node in the tree. We are starting to enhance that API by adding additional functionality. Things like if you have a constant path, we provide to you a method that will go and walk that subtree and give you each part as a symbol. A simple change, but enough that it is useful. So we want to start to extend our Ruby API to provide more functionality. Finally, we want to gather and create a contributor community around a single tool, this tool. I have heard from many people that are prolific in our community that they believe that a parser or a compiler or a JIT compiler or some of these more technically complicated topics should only be contributed to by people with advanced degrees or who have studied a lot. This is frankly bullshit. That's wrong. We have a shrinking community. That's the reality. We are 17th on Tiobe or whatever it is. We should not be adding artificial barriers to contribution in any place in our ecosystem. That is a mistake. Apparently, I have strong feelings about this. We should be lowering the bar. We should be lowering the barrier to entry in every place in the ecosystem. We should be inviting you in. You should not have to have an advanced degree. You should be able to contribute these things, and you should be able to contribute not because we said you could, but because it was obvious how to. You should have documentation. We should have tests. All of these things should guide you through contributing to this. This is a community that is human geared towards this. We have the right people for this. Everyone is nice. We can do this as a community. We don't have the technical side of it yet, and we need to. That is what we want to build. So, here's the crux of it. I've worked on parsing Ruby for 6 years. Parsing Ruby is not fun. I don't want to work on a parser. I want to work on everything that comes next. So many fun things to come. Building Ruby tools is very, very fun. This is Elm, and they have automatic formatting in their editors. This is TypeScript. They have automatic completion based on types. This is Rust. This is my favorite thing I've seen. It's called Flowistry. And what it will do, I'm about to click play, it will allow you to hover over specific variables in a scope and gray out anything that isn't relevant to that variable. Yeah, it's sexy. We can have all of these tools and more. You can build these with me. This is not beyond our pay grade. This is not beyond Ruby. This ecosystem is fully capable of building that. Let's go back to our example. What does this code do? How would you find out? This is the better question. I don't care what that code does. It actually raises an error. It tells you that string doesn't have a divide method. This is not the answer. It can temporarily be the answer. You're welcome to ask me questions, but it's not the real answer. The real answer is building an ecosystem of runtimes that get to work on what makes each one unique. It's building an ecosystem of tools that all agree on the Ruby representations. You want to find out what specific code does? Ask any tool. They should all agree. Lowering the barrier to entry for contributors around the ecosystem, and a community that works together to empower every tool and every person. This is the future of understanding Ruby. It's not the future of code understanding Ruby, it's the future of you understanding Ruby. It's the future of our community understanding Ruby at a deeper level. Let's build it together. So, I rehearsed this when I hadn't had 2 cups of coffee. And I went way too fast. So we have plenty of time for questions. Who's got one? Anyone? Yeah, it's a great question. So the question was, we extensively tested the escapes. How did we test that with the Unicode escapes? The answer is eval. I have this brute force test where we eval code in Ruby in every single encoding for every single context, for every single escape sequence. And then we check if we raise errors at the same time that CRuby raises errors. That test isn't going to work if they switch to Prism. because then we'll be the parser. So, but yeah, Unicode escape sequences are pretty fun because they can change the encoding of the string, which is a dumb, dumb thing that we shouldn't do. But it is what it is, and compatibility is what it is, so we're never changing it. What else? Yeah.
So you said this is shipping in Ruby 3.3. You also mentioned there are still some incompatibilities.
Yes.
How are you balancing that?
Great question. So the question is, this is shipping with 3.3. How are we balancing the incompatibilities that we have? We have a month. The incompatibilities that we have, I will say, are almost all we parse a superset of Ruby. So we parse more syntax than is allowed by Ruby in order to provide better error handling. And that's where 95% of our incompatibilities lie, because we should be rejecting more code than we are. And my thought is, like, screw it. We'll fix it in 3.4. If you're parsing valid Ruby, I can almost guarantee it's the exact same one-to-one. But if you're parsing invalid Ruby, then we'll fix it later. Anybody else? We have some issues. The question was, I want to contribute. I don't know where to start. We have docs. We have issues. Hit me up on Twitter. No, seriously, we do have smaller issues that are open that I'm purposely not touching. One, because I have no time, but two, because hopefully it will engender contributions. And I want to say this, if we have bugs and there's no obvious way how to start on it, that in and of itself is a bug, because it means our documentation is lacking to the point where you can't get started. So you can start with that. If it's not obvious how to contribute, then we need more docs. Yeah, there's a section in the documentation for background reading that you should start with. Particularly of interest would be, there's a section on parsing, which is a technique used to structure recursive descent parsers to parse expressions, and that is largely how we have structured the project. So that would be very useful for background reading. But start with the background reading. And if it's insufficient, then tell me, because then we'll add more links. Yeah. Over here? Yeah, it's a great question. The question is, how are we going to handle multiple versions when it's a handwritten parser? I don't know the real answer, but right now my thought is fork. Just fork it. And leave it as it is, and then require the correct version of the Ruby gem, and then you're not allowed to require both versions at any given time. I don't think there's any real reason for you to be able to parse 3.3 and 3.4 in the same process. I hope there isn't a real reason. If there is, I'm just going to tell you to fork into two separate processes, because your reason isn't real. Other questions? Yeah.
How did you get started writing parsers?
Yeah, how did I get started writing parsers? Oh, man. So I was working at a small startup before Shopify, and I was the only developer, so I had to write the front end too, and I got introduced to Prettier. Prettier, if you don't know, is a formatter for, it started as a formatter for JavaScript, but it became a formatter for pretty much everything front end. And I wanted to write a Prettier plugin for Ruby. And I didn't want to have dependencies, and so I wrote it using Ripper. Well, first, let's get serious. I wrote it using regex to start, because I didn't know anything about parsers, and I thought you could parse it with regex. And then I learned what a fool I was. And then I spent a long time maintaining the Prettier parser. And then I came to Shopify, and I said, let's all use Prettier. And Raphael said no. And he said no because it wasn't written in Ruby, which made total sense. And so I rewrote it, and I rewrote it into the gem called syntax tree. And syntax tree is a formatter written in Ruby. And I said, let's use syntax tree. He said no. Which is, you know, a battle I'm still fighting to this day. But maintaining the Ripper implementation was very difficult, because Ripper is not meant for that. It doesn't give you all the information you need. So I pitched to Ufuk, my manager, that we should write a new Ruby parser. And he said no. For good reason. I was working on Widget. There was no reason to pull me off of it. But then Shopify invests heavily in CRuby, Truffle Ruby, Sorbet, and uses RubyConf. And pattern matching hit. And all of those parsers were behind, except for CRuby. All of those parsers got screwed by pattern matching. 2.7 introduced an entire subgrammar that is a huge pain in the butt. And then we watched on our team as people spent 3, 4, 5 months not being able to work on their actual projects because they had to work on the parser, which is terrible. And then I pitched it again to Ufuk, and he said yes. Smartly. And that's how I got started. To be clear, I want to tell this story in particular because I didn't know what a parser was. This was 6 years ago I started on it. This is not an insurmountable problem for any of you. I'm not that smart, friends. You can do it too. And so I just want to emphasize that like, these things should be contributable, as I've said multiple times now. But it's not beyond you, it's just a lot of work. There's kind of this, I have time. There's kind of this intersection where we have simple and complex, and we have easy and hard. A parser is not complex. A parser is hard. It's a lot of work, but it's not particularly complex. It's just a lot of work. It just takes a long time. Anyway, yes, that's my answer. Long-winded as it may be. Yeah?
When you crossed out like the different non-canonical parsers,
Yes.
there were some that you didn't cross out.
Yes.
Are there specific reasons for why those, is it that those are still relevant?
That's a great question. So the question is, I didn't cross out some parsers. Why did I leave those parsers on the screen? Each one of them has a different reason. One of them was Tree Sitter Ruby. Tree Sitter is a project that generates a parser specifically for a particular use case with a particular structure around error recovery. It's used by GitHub to power their view. It's used by other Rust-based tooling. I'm never going to replace that. It's its own world. I think we probably could, but the amount of work that would go into it, because they have errors structured in such a specific way that I don't think it would be particularly worth it. And the people that run Tree Sitter would never accept it, so not worth it. There are a couple other ones. LibRuby parser is a parser written in Ruby, in Rust. RuRuby is a custom Ruby implementation written in Rust. We're never going to replace those. The other one up there was mRuby. It's my white whale. I will get it someday. That day is not today. The mRuby AST is very similar to the Lisp AST. I have no interest in fixing that right now, but I will one day, but not today. Yeah. Any other questions? Yeah.
Why the name Prism?
Great question. Why the name Prism? It started out as Ruby-parser. There was also a project named Ruby_parser, so that was going to get rejected pretty fast. We renamed it to Yarp, yet another Ruby parser, and then Mats was like, that's a terrible name. So I was like, all right, we'll rename it. And then we came up with Prism, and then I came up with some acronym for it, which is like, parsing Ruby is suddenly manageable or something like that. Yeah, I don't know. It's, I did find out that there was like a Prism library that was used in like the Snowden leaks or something, which is like very embarrassing, so probably shouldn't have mentioned that on stage. Anyone else? Yeah. Yes, so the question was, what are the plans for round-tripping back to the source code? I've been working intermittently on redoing syntax tree, effectively, to be able to format code back to source. There's like 40 failures left or something like that, but my plan is to, right after 3.3 is released, to spend a little bit of time and get that out. So if you use syntax tree for your formatter, or if you just use it as a library, in the version of Ruby that will ship after Christmas, I'm gonna, as soon as it's stable, I'll release the new version of syntax tree, and it should be like in like orders of magnitude faster, because the parser I wrote was not fast. So, and you can use that, and then the unparser gem should also be able to work with that to also go back. All right, I'm gonna call it. Thank you very much, friends. I appreciate it.